Hi, this is Mr. Cardoso, and in this video let's take a look at this example. Find all values that make the inequality, here we have it, true, and write your answer in interval notation. Okay, so let's start with this. The first suggestion is to bring everything over to the left hand side and say less than or equal to 0. So let me do that. So I get x plus 3 over x plus 1 minus x minus 2 over x minus 3 is less than or equal to 0. So I brought this over to the other side and just left 0 on this one side. Now the LCD is going to be just the denominators, the two denominators, x plus 1 and x minus 3 multiplied together. So there's my lowest common denominator, and so I go ahead and I put this down here at the bottom to make it common. So x plus 1 and x minus 3. Now I have to ask myself, I multiplied this by x minus 3 because that's what's absent here. So up top I'm going to have x plus 3, which was originally there, and then x minus 3, which is this part of it here. Okay, and now this part I had to multiply by x minus 1, so this is this minus sign that goes there, and so I still have this x minus 2, and now I have the x plus 1. Okay, so you have to be careful with these minus signs, make sure it stays there because this whole numerator is in brackets with that minus sign, so we multiply it by what's missing. In this case it's the x plus 1 from the LCD that's missing, and that's all less than or equal to 0. Okay, so now I go ahead and I work through this numerator. You can see actually this is the reverse of the difference of squares, so the numerator is going to be x squared minus 9. If you do the difference of squares on this, you will see that that's equal to that. And then I have a minus sign here, and let me work through this. So I'll put some brackets around this. I have to do a FOIL here, so I get x times x, which gives me x squared, plus x minus 2x minus 2. Okay, and so x squared, let me just check this, x minus 2x minus 2. So you're always good to check your work, of course. And then x plus 1 times x minus 3, and that is less than or equal to 0. Okay, let's continue to work out the numerator. So if we get rid of the brackets and expand this, we get minus x squared, and now we have x minus 2x, which gives me negative 1x, but then there's a minus there, so that gives me plus x. Okay, and then minus 2 gives me plus 2 all over x plus 1 x minus 3 is less than or equal to 0. Okay, so let's see if we can simplify this numerator further. The x squareds will cancel out, that's kind of nice. We're going to end up with x, and then we have minus 9 plus 2, so x minus 7 over x plus 1 and x minus 3. It's just less than or equal to 0. Now, we need to take this, now that we've simplified it as much as we could, we need to take this and figure out our zeros. Our zeros happen when the numerator is equal to 0. In other words, if we take this as a function and ignore this side here, if we take this as a function, we set y to 0, and then the denominator will actually cross out and give us 0. So we take the numerator and set it equal to 0. So we get x minus 7 equals 0. We get x is equal to 7. So we only have one 0. And then we need to find our asymptotes, our vertical asymptotes. Because these are the things that are going to divide up our x-axis. Okay, so our asymptotes divide up and our zeros divide up the x-axis. So we have two asymptotes. We have x equal to minus 1 gathered from this x plus 1. We set that equal to 0. And we have x equal to 3, positive 3, because that, if we put a 3 in here, that makes this 0. So setting the denominator equal to 0 gives us our asymptotes. Now from these three, we've got this point, the 0, and then -1 and 3 as our asymptotes, we can divide up our x-axis. So if I draw a quick sketch here just of what we have, not of the graph itself, but just looking at these points. So I've got a 0 here at 7, so there's 7, and then at -1 and at 3 I've got asymptotes. Okay, so these are my asymptotes here. I've got asymptotes, and here at 7 I've got actually a point, so it goes through there. Okay, now from this information you can see that because of this, what this is saying is that the graph might go above or below the axis after between these points. So here, for example, it might be above, and here it might be below. So that's at the asymptote there may be a switch, and at the 0 there may be a switch. So that's why we use these points, the zeros and the asymptotes, to divide up our x-axis. So now we set up a table. Since we have three points that divide up our x-axis, that means we're going to have 4 intervals. And so I'm going to make a 5 by 5 table. So I have enough space here. Just going to move it down. Let's see if I can move it down here. Make a 5 by 5 table. Here we go. Okay. Now, in this 5 by 5 table, I'm going to use my points here to divide up into intervals. So really, what I have here is I go from the smallest one. The smallest one out of the 3 is -1. So I'm going to go from -infinity to -1. Then I'm going to go from -1 to 3, and then I go from 3 to 7, and then I go from 7 to infinity. So these are my intervals. And now I take a look at each one of my factors, and I put my factors in here. So if I take this, I'm going to have here x minus 7. Another one I have here is x plus 1. And then I have x minus 3. And then the last row here is for the whole thing. So we have x minus 7 all over x plus 1, x minus 3. Okay, so we need to look at these things here, and this is the overall thing. So what we're doing is we're going to pick a value in this interval, and we're going to evaluate at that value, is this factor positive or negative, and then overall, is the whole thing going to be positive or negative there? Okay, so let's say a value in this interval, -infinity to -1, is safely -2. If I plug in -2 here, -2 minus 7 gives me -9. The important thing here is the negative. So I know that's negative. Now, if I take -2 and plug it in here, this is also going to be -2 plus 1, which will give me a negative. Okay, and if I plug in -2 here, I'm going to get negative. So what I'm going to end up here is negative on the numerator over a negative times a negative. So negative times a negative is going to give me a positive on the bottom. So I'm going to get a negative divided by a positive, which gives me overall, I can do this in red, a negative. So this is where I'm less than 0. In this interval, I'm less than 0, and that interests me because I'm looking for where this is less than 0. Okay, so now let's check the next one. So from -1 to 3, a nice number in that interval is 0. I can pick any number in that interval, and 0 is nice. So if I plug in 0 here, I'm going to get a negative. If I plug in 0 here, I'm going to get a positive. And here I'm going to get a negative. So now I have a negative on the numerator. This is the numerator. And on the denominator, I have a positive here times a negative here. So the bottom is going to be negative. I'm going to end up with a negative over a negative. And so my overall is going to be positive. Negative over negative gives me a positive. So in that section, it doesn't interest me, it doesn't satisfy this because this is where it's above the x-axis and I'm looking for where it's below the x-axis. Okay, now here, 3 to 7, nice number there's 4. If I plug in 4 here, I'm going to get a negative. If I plug in 4 here, I'm going to get a positive. If I plug in 4 here, I'm going to get a positive. So I end up with a negative over a positive times a positive, which is positive. So negative over positive is going to give me a negative. So that whole section does interest me, and I can probably assume this is going to be positive as well, but let me just go ahead and complete this. So this is going to be positive 8. Let's choose 8. Sorry, the number I chose here was 0, and the number I chose here was 4. Okay, so 8, if I plug in 8 here, I get 1, positive 1. Here I'm going to get positive. 8 plus 1 gives me 9. And here I'm going to get positive. So I'm going to get positive, 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 which is going to give me, of course, overall a positive. So this section doesn't interest me. So the two sections that interest me, or the two intervals that satisfy this inequality and therefore satisfy the original inequality, is going to be from negative infinity to negative 1 and from 3 to 7. Now, we have to look at how we place our brackets because the question asks us to do this in interval notation. So the brackets are where we need to be very careful. So we need to look at these values now and remember that some of them were asymptotes. Negative 1 and 3 were asymptotes. So therefore, there is no graph at an asymptote. So they cannot be included in the interval. So what we should do is disclude the negative 1 and 3 automatically because they are asymptotes and there's no point there. So they cannot be included in the interval if there's no point there. So those are discluded. The negative infinity is never included because negative infinity or positive infinity can't be included as the number itself does not exist. Okay, so we finished that one with the brackets. Now the 7, is the 7 included? Well, the 7, there's a 0 there, so there is a graph at 7, there's a point at 7, the function does exist there. The next thing we have to check is our inequality, because at 7 we know the graph is exactly 0. So our next question is this a less than sign or a less than or equal to sign? And in this case, it's a less than or equal to sign. So 7 should be included. In the event that this was just less than, we would not include 7. We would disclude 7 because 7 does not belong to the set, the solution set, because 7 is 0 and not less than 0. 7 makes this 0 and not less than 0. So that's where you have to be careful. Asymptotes are never included. Infinities are never included. And for the zeros, you have to check, is it less than 0 or less than or equal to or greater than or equal to 0. So you have to check the zeros. So that's pretty much it. These are the solutions, and I hope you understood that example.